Super excited to have you here. Funny enough, I originally met you in Spain. I think it was during the Avalanche conference, and we were both at a event together, and I came up to you and just started badgering you with questions on how blockchains work and decentralization. And so excited to have the conversation here again.
Yeah, no, thanks so much for having me. And it was a great chat. I hope you didn't get too sick after the Avalanche conference. I know there's a lot of folks that got COVID following it, myself included.
Oh no! I went to the Breakpoint event in 2021. That was in the November timer frame, so a couple months before the Avalanche event, and I got super sick after that. And so I think just going through that first initial round and traveling overseas kind of spared me from the Avalanche event. But it was a good event overall. I had a lot of fun.
Good event for sure. Yeah.
So I would love to start the podcast with a little bit more about yourself and kind of just in general your background and then kind of your journey into crypto. I think everybody has a unique story. The rabbit hole can often go pretty deep. So I would love kind of for you to explain in your words how you got involved in tech and then how that brought you into the blockchain and crypto industry.
Yeah, no, for sure. Myself, personally, I've been kind of always fascinated by, security and networks, right? And I think, you can see that throughout various projects that I worked on. After my undergrad, I did a little bit of work in research in like software-defined networking, right? So our goal was to build like, distributed controllers to manage decentralized networks effectively, right? And, we're not talking about like a second or 5 second blocks there. We're talking about, microseconds, nanosecond responses there that we needed to get to. So, it was pretty fun. Afterwards, I did grad school. So I did PhD at MIT, doing a lot of cryptography work and, protocol design. Started to play in the blockchain space by the end of my grad school. So some first projects with, Sergey from MIT, and we started to collaborate on, some of the early works that led to our grant effectively at the end of the day. And, I spent a bit of time as a faculty at the University of Waterloo in the middle. So, did a lot of research there in systems cryptography, but then took a leave to focus on startups, right? So we helped to take the Algorand to the market, and, we launched that platform. And then afterwards, just trying to understand where is the ecosystem going and like what are the important problems that we have to solve, right? And I think one of the problems kept on coming up is the spread of different blockchains ecosystems, right? And, it's been kind of a morphing over the last few years, different activities and different chains and like how they interact with one another. But I think no matter what, kind of underneath all of this, like you really need robust communication across different primitives in the blockchain space, right? And I think, that's a problem that, is technically very, very challenging, as you probably know. But to me, that's super exciting to work on, and been working kind of on Axelar in this problem for the last couple of years.
Perfect. Well, before we dive deeper into Axelar, I would love to kind of learn a little bit. Well, let's start with kind of some of your learnings from Algorand. Like, I think that's super unique, and being able to kind of bootstrap like your own like layer one. And building that from the ground up. What were some of the biggest lessons that you learned while kind of bootstrapping and building that ecosystem?
Yeah, the single lesson that I think I like to stick to now is that innovate on a new problem once a year. Right. So I think one of the things at Algorand that we try to is kind of innovating across the stack, right? Everything like from consensus to smart contracts to, economic principles, go-to-market, distribution, and everything else. It was a really creative team, right? Everybody came from kind of very strong backgrounds. Everybody's ambitious. We all want to kind of, solve important problems. But I think as a result, we kind of took a little too much, a little too, too fast, right? And so then you have this, but you have to focus on something. You really have to say, what are your core, objectives, and like what are the core value that you provided to users, whether or not it's developers or end users, right? And you have to, you have to explain what you're doing, right? Like even if it's a complicated stack, it doesn't take you, 3 months to explain what you're doing. Like it takes years of education and tooling, right? And everything else that has to be built around it. So to me, that's sort of a principle that I like to follow now, like one major innovation per year.
I love it. And yeah, unfortunately, the blockchain industry is highly technical, and there is lots of small nuances that often you do have to have some type of technical background or computer science degree, and it even helps to have a PhD in like distributed computing to understand these. And so I really look forward to the day where we kind of abstract a lot of the complexities, similar to like what Axelar is building to make these easier on the end users, because it is hard to understand and definitely hard to communicate sometimes. But one of the things that I think would be maybe interesting to start with too, before we jump into kind of more of Axelar, is maybe rehashing some of the conversation that we had in Spain, and just like talking. I think I can't remember exactly, but like high level, like what are some of the biggest like bottlenecks that you see today in just kind of like blockchains and blockchain scaling in the industry?
Yeah. So I think our conversation was around kind of a vertical versus horizontal scaling, right? Premises and kind of how which way should we go, and kind of what the stacks need to look like, and related questions. So to me, I think this is still one of the core questions that's still not solved, right? Today, which is how do you scale kind of a blockchains, right? There are various analogies that people are making for blockchains, which is some of them say it's a database, right? Some of them are, saying that serve a network, but maybe it's a kind of a hybrid, right? Like to me, what a blockchain is kind of actually a beautiful combination of both sort of a database, and networking properties, right? But also high distribution properties. And so, how do you scale these environments? Do you optimize this kind of read-write request at the database level? Do you optimize how fast the messages propagate? Do you scale horizontally and have more different, solutions from like layer 1s to layer 2s and things like that? And I think it's still a question, and it's not only from a what do we need to achieve, millions of kind of transactions per second or things like that, but also how does the user experience change in all this? Because no matter which path you take, you are either making better user experience or you're actually making some trade-offs, and then you have to build some other architectural components or building blocks to, solve that user experience, right? Some of the things, we're working on as well. And so I think these trade-offs are still being investigated, but I would say even since the last, conversation that we had, the horizontal scaling direction's been actually exploding more and more, right? With layer 2s, I think now getting traction, a lot of zero knowledge technology, right? And like roll up technology and things like that. So I think that trend kind of continues pretty strong.
And yeah, I love to hear this, just because you've spent so much time kind of in the deep technical sense with doing your PhD and even teaching courses. So in your mind, do you think, you said like the kind of horizontal trend will continue. Is this kind of like what you think will be better for like the end users? Or I guess ultimately, where do you think it ends up? And maybe this is kind of a good segue into Axelar and what you decided to build there. But what do you think is the end state of these blockchain networks to scale to, say, 100 million plus people?
I think my pretty strong, hypothesis / conviction that it is going to be horizontally scaled, right? Now, when I say horizontally scaled, it doesn't mean, it needs to be like, that could mean different things, right? You can have many chains, you can have many rollups, you can have sharding, right? That some protocols have, like near and things like that. And so there are, I guess, fundamental physical limits, I think, what you can do on a single threaded environment, no matter what that is, right? For the same reasons as like the internet, it doesn't actually run on one database. It doesn't run on one network, right? Having systems that can independently evolve, independently fail, and independently mature is actually benefits everybody in the long term, right? It allows some people run on their own speeds. It allows innovation to continue happening faster. And that's what we're seeing actually right now with layer 2s, right? Where you have innovation like things like account abstractions being pushed by layer 2s way before, Ethereum is adopting those technologies. So yeah, I think strongly for scalability issues, the system has to scale, in a horizontal way. And that does introduce difficulties for developers and users at the same time, right? So developers have to think about how do you build in this paradigm with asynchronous communication and things like that. Users need to, think about how to interact across all the systems. At the end of the day, technical problems for developers and for users, all of that, can be solved. It's just a question, like, what are the layers that need to be built to solve those things? But yeah, I don't see, a single environment that can possibly process very, very high throughputs. And, we can't do that with regular networks and databases. It's just, there are kind of a fundamental limits that you have. You have resource constraints that start happening, right? Like one application all of a sudden has a burst of traffic and then everybody else drops. You won't be able to deliver quality of service to the users unless you're able to isolate system resources from one another for different workloads.
Definitely makes sense. Yeah, I'm super fascinated by this. I'm curious to see how it ends up long term and the different trade-offs of these different systems and how ultimately it does affect users and the engineers as well. But maybe that's a good jumping off point to talk about Axelar and scaling kind of horizontally. Could you share the vision for what spurred Axelar? Why you decided to pursue building kind of this protocol?
Yeah, so the first motivation actually came shortly after we launched the Algorand platform, right? So after launching it, we wanted to connect it with, some of the major ecosystems, like Bitcoin, Ethereum, and a few others, right? And then ideally, like I said, we've been innovating on the stack so much that in an ideal world, we would be able to call someone up, right, and say, could you connect that Algorand with all these other chains, right? But unfortunately, there is no protocol, there is no company, there's nobody that was solving, the problem, and the existing solutions, like IBC, it was kind of a clear that they would take kind of years of engineering, and frankly, we'll have to rewrite pretty much the consensus to support those types of approaches. So there have to be better. What I call as a plug and play, right? Protocols that would work, and you can continue to innovate and you can continue improving them, but you need connectivity tomorrow. So you can't spend 3-4 years kind of a design in some of these things. And so that's what led to some of the early motivations behind Axelar. And then it was clear that the protocol and the system that we designed to solve the issues for the ecosystem needs to be chain agnostic, right? So it needs to be able to plug in, it needs to be able to scale, it needs to be able to evolve as different ecosystems evolve, it needs to be able to deal with failures with different ecosystems, right? So when one ecosystem goes down, and for instance, we lived through this through Terra when it was going down and up and up and down. And so you have to have very strong properties at the kind of core consensus layer to deal with some of these failures, right? To deal with some of the connections going live with efficient, routing, message translation, like path discovery and things like that. And so that's what led us to, think about Axelar. The end goal of what we're trying to do is to empower developers to build chain agnostic interchain applications, right? So kind of a change in the developer paradigm, and as opposed to saying, okay, build on this one chain and then think about connectivity. How do you take a step back and say, how does my architecture and how does my application need to be built maybe from day one, so it can scale up and down as new ecosystems are discovered, right? As new connections need to be made, as new users or liquidity needs to flow from another connection. So that requires, different tooling. It requires different, different protocols underneath it. And at the end of the day, we want to empower developers to build, scalable interchain applications. And finally, we want to be able to allow users to access all these ecosystems with one click, right? Today, if you are a blockchain user, you have to change wallets all the time. You have to think about, how do I get gas on this chain just because I want to play with this application, right? How do I need another wallet because it's Cosmos or Solana or Ethereum? And so those things are very, very complex for the users. And so empowering developers with the right stack ultimately enables users to interact with all of these different applications, all of these chains with one click, and much, much simpler, right? Which I think is also a key problem to solve, is really, like you said, simplicity. Otherwise, it's kind of a very hard to use today.
And being able to kind of instantaneously deploy kind of multi-chain, could you walk us through that? Because I think that would be really interesting from like developer perspective, or at least have like with the mindset of like, when I launch this application, I want it to be on multiple chains instead of just a single ecosystem.
Yeah. So we have a blog on our website, which, at the very core explores like two extremes of architectures in the multi-chain world, right? Let me kind of give you examples. So one is what we call as like peer-to-peer multi-chain deployment, meaning that you have an application contracts that talk to one another in a completely kind of a peer-to-peer identical way. And then you can scale those contracts as different ecosystems are discovered, right? So today deployed on 3 different chains, another 2 chains are available tomorrow. You want to access them, you can deploy the same contracts. They all have peer-to-peer relationship with one another, right? So one example of this would be something like an interchain token, right? So if you have a token, you want to be able to send this token not just within the same users of the same blockchain, but you want to send it to someone else who has a wallet or wants to play with an application on a different chain, or you want to use this token in a different application on a different chain. So you can design a contract for this interchain token to be in a completely like a peer-to-peer symmetric relationship with one another. These contracts effectively like burn and mint tokens as they travel from one ecosystem to another, right? So that's one architecture extreme. And then the second one is what we call like as a home base and satellite model, right? So you have a home base chain where you can deploy a smart contract where most of the logic lives. And then you have satellite contracts that don't do much other than like sending messages to your home base chain, getting approvals for those messages, and then sending messages back to the satellite chains. And, certain actions can take example. So examples of applications that need these types of architectures are things like, borrowing and lending. And I think like Prime Protocol is one example of this, is where, if you want to take a loan against your asset in a different asset, then it's actually, somewhat hard to synchronize like what the pricing of this loan should be, right? Like how much collateral is available in the system and things like that. So you want to, synchronize all that state as much as possible in this like home base kind of contract, and then, but still be able to authorize requests from different chains on the user so they don't have to think about those back and forth interactions. So this is the second extreme. And then as more chains are available, then you can say, okay, I can deploy more satellite contracts, right, to all these different ecosystems and kind of continue tapping into those users and those assets. And you can, of course, have something in the middle, right, in the hybrid model where some things are completely symmetric in terms of relationships. Some messages have this kind of a home base and satellite, approach. But those are, kind of the two core, I would say, architectural decisions that you have to make as you're building this application and then scale from there.
And maybe for the less technical people, could you kind of like a high level map like those two different architectures to two ecosystems that exist today?
To ecosystems, you mean like to specific applications, or like?
I guess like either applications or like blockchain ecosystems. Like, do those map more to like a layer 1 ecosystem in one sense, or do they better map to applications?
I see. I mean, from my perspective, I guess I'd like to think about application, deployment model. And maybe what you're going to is that, some ecosystems really have evolved in like peer-to-peer or hub and spoke models, right? Like Polkadot is a good example of a kind of hub and spoke model, right? That, has a main relay chain, and then you have all these parachains that talk through the relay chain to one another. But the logic, I guess to your point of when a parachain is allowed to join the system, right? What happens when it fails, and communication is all done through this main kind of Polkadot sort of relay chain, right? If you take that from an ecosystem and then map it to the application, deployment model, right? That would be something similar where you have kind of home base, what I called is your main logic of an application, and you have these satellite contracts on other chains that talk to this home base chain, right? So, and then when it comes to peer-to-peer, I guess the analogy, if you're familiar with ecosystem, would be something like Cosmos, right? I would say, pretty much everything within Cosmos has a kind of peer-to-peer symmetric relationship via the IBC protocol. It's starting to change a little bit with this, like interchain security narratives and things like that. But, so far, it's been mostly peer-to-peer relationships. Anybody can connect. Anybody can talk to one another in a symmetric way through the IBC protocol, right? And now, if you map that back to the application, like I said, I think a good example would be like an interchain token, right, that talks to one another. You can define packet format for this interchain token. It's all symmetric. New tokens can be deployed and still talk with existing token deployments on other chains, right? So completely like symmetric model.
Gotcha. Yeah. Very interesting. And so wrapping it back to, so we initially kind of started with this blog post and how it relates to like developers and like the ecosystem. Could you tie that back to like Axelar and what you're trying to accomplish there?
Yeah, so what we're trying to do at Axelar is really build this kind of a connectivity tissue, right, across all of these different blockchains. And when I say, connectivity tissue or infrastructure, it's really a combination of three different like layers in the stack. There's Axelar network itself, and you can think of it as a decentralized network, powered by proof of stake consensus. That's job is to connect, right, other blockchains and route packets back and forth across them. So the protocol has inherently been designed to support things like many-to-many routing, right? So every time a new ecosystem is added, it's automatically interoperable with everything else. So it's not like a pairwise bridge relationship. It's really kind of a many-to-many hub that you connect yourself into, right? There are things like, translation of packet formats. So we process a lot of traffic between like Cosmos chains and EVM chains, right? So Cosmos chains have one type of a stack. It's sort of consensus based around like Cosmos SDK. Some of them have kind of Cosmosm or smart contracts. EVM chains have a very different language, right? So it's Solidity. It's things that, developers write inside of smart contracts, not at the consensus layer. So how do you translate messages between these two ecosystems? So you need to put that logic somewhere, right? And if you don't put it, in the network at the consensus layer, then it would have to be like at the application edges, and the users and the developers would have to pay all the associated costs with them. So it's a lot more efficient to do it at the consensus layer. And finally provide security, right? The Axelar network itself and various strong robustness properties, like what happens when an ecosystem goes down, right? Like what happens if there's an attack. So we employ things like, rate limits to make sure that like, even if one ecosystem is down and like it starts faking packets, you can't pollute that into all other ecosystems. So that's a lot of work at the kind of network layer, right? It's a blockchain that connects other blockchains. You can think of it that way, and you can program it to do a lot of those interesting things. And then on top of it, we have what we call as like service layer, right? So things like, relayers, things like execution of messages by paying gas with one click on the source chain. So if you have a transaction that needs to touch 5 other chains, how do you do that so the user only pays gas once and never has to think about execution on other chains, right? So things like gas services, things like relay services, things like monitoring of transactions across chain to give you precisely understanding like what is the state of the transaction, where it's at, did it revert on destination or source chain, things like that. So that's a kind of a infrastructure layer that built on top of the Axelar network. And at the very end of it, what we expose to developers is actually really, really simple. It's like 3 function calls at the smart contract layer that you can just call to send a message, right? But underneath all this is like complexity, how to execute it. But from a developer's perspective, it should be, I want to send a message, where this needs to go, what is the destination, I sent, and I forget, effectively.
Perfect. Well, I would love to, a lot to break apart there. I would love to, let's start with kind of the message passing. I think of that from a technical standpoint is very interesting. Could you maybe go a little bit more in depth in how Axelar specifically does the message passing between these different blockchain ecosystems?
Yeah, great question. So Axelar network connects with blockchains by effectively deploying what we call as a smart contract known as a gateway. Right. So a gateway, you can think of it as a router. Okay, like you probably have at home a router. What does that router do? It receives messages from your home computer or your laptop, right? And then it figures out where they need to go to reach the destination, right? So if you're talking to Google or Netflix, those messages need to be routed, and things like routers are responsible for this. So then on every chain that we connect, there is a notion of the smart contract, which is a gateway, aka router, and that exposes an interface for applications that they can write and read from. Right? So you can send a message to this router and you say, I want to go from Ethereum to Avalanche, as an example. Right? Underneath that, then their Axelar network will listen for events coming into this gateway/router, and then take those events and then process them. Right? It doesn't process them, in any centralized way. The network itself is decentralized, so there's a consensus that takes place across all of the Axelar validators that decide what needs to happen with that message. Right? So, as an example, if you send in from Ethereum to Avalanche, it's confirmed by the validators first. They all agree that this is the message. They all agree where it needs to go, and then they generate another outgoing message, you can think of it that way, that is then posted on the destination gateway, and from there it can be executed by the application, right? Inside of that message, you can, of course, have all kinds of code or smart contract interactions. You can call other contracts, you can mint tokens, you can burn tokens, you can perform callbacks and things like that. So it's a completely, what I call as like a cross-chain Turing-complete communication environment, right? You can write an arbitrary program, you can deploy an arbitrary program through this message passing paradigm, and that's what makes it pretty powerful.
And one thing that you mentioned earlier also was kind of the different programming language or virtual machines. How does the being able to connect with the different virtual machines and these different ecosystems affect the message passing, or does that add additional complications for the team on the engineering side?
Yeah, so we made it so that our network effectively can translate messages from one ecosystem to the other, right? And I think the most famous example, like I said, like we're translating across like Cosmos chains and EVM chains, right? The messages. Now, how it's done, it is some work on the engineering you have to do to accomplish this, and we kind of designed the network to have a lot of like the right kind of building blocks to do that as efficiently as possible, right? So things like, registering validators to be able to kind of subscribe a different chain via like RPC endpoints, having things like, cross-chain voting gadget that is completely, uniform across all the different stacks, and you can reuse them no matter what the consensus you have. Having things like multi-party sign-in, right, where the majority of validators need to, sign a message one way or another, whether or not it's, multisigs or things like that, but agree on that format, and then, generate a message and post it at the destination chain, of course. So yeah, adding new ecosystems, it does come with, additional, I guess, engineering work if it's not a VM or like IBC and things that are programmed, things that like one time, it does require work, but all the building blocks are there and you can sort of compose them as easily as possible to make those connections.
Makes sense. And one other thing that you mentioned was kind of the composability aspect or being Turing complete. How, I guess, like in the perfect state or end state in kind of a perfect world that you envision, would the ideal state be deploying just to Axelar initially, and then you're being able to take advantage of like all these different ecosystems?
Yeah, so the deployment process, is something we're still kind of working through. But yes, effectively, Axelar, having a programmability allows you to do those things in a uniform way, right? So, for instance, one service that we actually exposed, which a lot of developers like, is this notion of a constant address deployer, right? So the idea is that if I have a smart contract, it needs to live on different chains. how to actually refer to it in the same way, having the same contract address, right? It's not that hard to do, but you have to take care of like nuances and things like that. And so giving a developers like this environment and saying, yes, you can deploy a contract. It's going to be the same contract across all the chains. So it's easy to aggregate information from it, right? It's easy to parse it. It's easy to scale it as new chains are added. These types of kind of features and properties we'll provide at the network around it.
Interesting. Very cool. And then one other component that you mentioned was that I want to talk about was like the node validators just running the proof of stake network. And then I want to jump into some of the services. But on the now validator, how does Axelar in general kind of view decentralization by running its own proof of stake network? Kind of like, do you have to have like super beefy nodes? Are they small nodes? Do you have a lot? I would love to get your thoughts.
Yeah, so Axelar itself is built around kind of Tendermint consensus, right? So the nodes that you run, they're not that beefy. They're pretty standard, kind of server grade machines for the most part. Axelar validators also do connect with other chains, right? And so those connections can sometimes mean that developer or validators need to register for like RPC endpoints of those chains, right? So, if you go to things like axelarscan.io, which is, an explorer, you could go to like a validators tab and you can see which validators registered on which chains, right? So it's kind of opt-in protocol, but enough validators, need to register to actually vote on the events from those chains. So it's not, the core validator itself is not that beefy. It's not that hard to run. But you do, if you want to get rewards and incentives from other chains, you do have to run like adjacent nodes on the side, for the chains that don't have like clients or things like that, right? So yeah, in terms of kind of your broader question, like how do we view, decentralization, right? I mean, I think it's like the core, right, of everything we're trying to build in the blockchains, and not just for, any type of kind of philosophical reasons. I think decentralized systems give you the strongest, safety and liveness properties, period, right? And I think we've seen that over and over again. In the ecosystems, we've seen all the attacks on like centralized bridges over the last year, right? Where you have like a very small kind of a multisig and people going down and attacking those things. So yeah, if you want to build something that lasts, if you want to build something that people can rely on for years to come, you have to have decentralized protocols, and you have to work on scaling those decentralized protocols, right? Today you start with one number of validators. How do you get more validators? How do you make the requirements for joining and being a validator lower and lower, right? You have to continuously think about those questions.
Lots of hard engineering problems, that's for sure.
For sure, yeah.
So maybe kind of wrapping up some of the tech stuff, the other component that you mentioned was the services, and how those kind of take advantage of what the Axelar team has built. Could you talk about the different services that Axelar provides?
Yeah, so the basic ones are things like relaying, right? So while the network itself, and I think that's actually a pretty critical point to understand. So the Axelar network is effectively responsible for validation of the messages, but relaying of physical packets like from one network to another is completely permissionless and can be done by anyone on top of the network itself, right? And that's actually critical because that means that you have much stronger isolation between these like two core properties of liveness and safety, right? So you get like safety from the network itself. Liveness, you actually need a much weaker properties there where you need like just one person, right, to relay your messages for liveness, and then you can achieve very strong liveness properties by having a few redundant nodes if you need to, right? And so, this basic service that I think, we provide is like, okay, we just relay packets, right, for the people. But having the permissionless relaying means that we have like some other folks like build independent, relayers, right? Where it can say, okay, this is a completely different component, and I would rely on that if something happens. We actually expose an SDK where the user can relay their own messages, right? If they want, again, like for whatever reasons, if you want to relay it, and we have some partners that are doing that and like leveraging. So this is the basic one. The second service, which I think is really important for usability, is what we call as a gas service, right? So the basic idea, as I already mentioned, we want to allow a user to execute a cross-chain or multi-chain transaction with one click by paying gas only once, right? And then execute this transaction on different chains. So the gas service effectively says, okay, you can pay to the smart contract, and this kind of a relayer architecture will take your transaction and make sure it's executed on all the other chains, right? And for some messages, we have developers that actually write in like back and forth calls, right? So I want to make a call to another contract on a different chain that returns back a result to my original chain and then executes a function if and only if this other contract authorized my decision. Right. So how do you, again, program all this interaction with one click from a user perspective? So that, I guess, like the point is that we don't have synchronicity, right? When we're doing multi-chain interactions, we are working in an asynchronous environment, but we can build these service and building blocks to allow users to still experience synchronicity in some sense, right? And that's what we're trying to do with all those services. And then a lot of services for developers that allow them to, monitor transactions, like hook up into their front ends, right? So we have Axelar Scan, which is effectively like interchain explore, right? And that allows you to say precisely how much time it takes for a transaction to execute across chains, has the gas been paid, why it's not executed, allowed to resubmit and retry and things like that, right? So those are kind of again, like experiences that we're enabling for the developers to then build these types of, I guess, synchronous primitives and building blocks.
And out of curiosity, I guess you're ultimately kind of bottlenecked by the slowest blockchain for the different two that you're interacting. Do you have like some data around like the average confirmation times in between chains and how much some of the message passing costs in between like these individual systems?
Yeah, so we do. So again, like if you go to like Axelar Scan, and then like there's a GMP tab, and there's a tab with statistics, right? So, and you can see. Let me actually, pull it out so I can tell you some statistics. But you're right that in the worst case, right, we are always waiting for the slowest chain and the confirmations on it, right? Let's say we look at like last 7 days, then we've seen like from Avalanche, an average transaction take like a minute to execute, right? That includes all the way, right, from, finalization in Avalanche to like relaying, right? And then execution on like destination chains. And I don't know in this case what the destination chains are. Ethereum is the slowest. Oh, I guess like Arbitrum is the slowest right now, because it's like layer 2. So it has to wait for its own finality. Plus it has to wait, Ethereum finality, and Ethereum finality with the merge is actually lower than it was before. Or higher latency that you get from Ethereum now on average. But that being said, like we actually have a couple interesting, things that will come up that would allow to speed up a lot of these things for some applications. So, kind of stay tuned, but like in a couple of weeks, we'll be able to share more.
Any little sprinkles you could share today?
Let me just say, like for some applications, right, like you don't need actually to wait for full finality, right? So the idea is that, for some applications, you can design it in such a way that you can take a risk with much lower finality, but that risk is, completely justifiable from an attack and economic perspective, right? And so, there's like certain objects that we're working that would enable that. And then you can, pretty much settle things with almost like instant finality.
Very interesting. Looking forward to that. Excellent. So one thing that I like to kind of go deep into the technical aspects, but then be able to wrap that back around to some of the user facing or kind of perspective. So one of the things that we've seen last year is kind of some of these attacks. People, I would say, a little hesitancies to use some of these systems. How would you describe like the real world use cases of Axelar, and what the user could experience, and why or why not should they be nervous about kind of these things that have happened in the past?
Yeah. So I guess great question. There's many, I guess, sub questions, right? There's like kind of security, user experience, right? And, then the Axelar itself. So let's start with security, right? Aspects, I think. And, that's kind of quite important. I think security at the end of the day, comes down to actually having a combination of the right architecture and decentralized stack, good engineering practices, and all kinds of safety features or application safety feature add-ons, right? And what we have seen in the past is, as you said, most of the attacks in the space been because protocols have been designed just like completely centralized, right? You have kind of a 5 multisig or something like that. So keys are compromised, or there's like a bug in the smart contract, and then all the funds can be leaked. So having the right design, the design that is actually secure and can continue scale in a permissionless and decentralized way, I think it's critical. If nothing else, then what we have seen through decentralized protocols and designs is that you have diversification in terms of deployment, right? So every validator takes the job very seriously, like they decide how to protect their systems, how to protect the keys behind the validators. And so the more diversified you have, software deployments, the more practical security you can get, because the cost of attacks keep on going up, right? So that's one. The second thing are kind of engineering practices, right? So you can never spend, I guess, enough on the safety of those things, right? So you have to have tests from end to end to unit tests. You have to have bug bounties. You have to have audits. So we run like over 2 million bug bounty. We've done like 30 audits plus like on the network, like throughout the stack, and all the major features are going through multiple code audits and things like that. And then there's like things like, what can you do for applications to even make it safer, right? To use and by all these primitives, and that's sort of no different, than like in the early days of exchanges, right, or DeFi applications that was shipped. Like it didn't have all those design principles. They didn't have audits, and people ended up losing a lot of funds, right? So, an application perspective, you can do interesting things. You can say, I have like things like rate limits, basic things, right? So an ability to be able to, say, okay, my network needs to process this much, or my application needs to process this much per hour. Maybe I'm still in the early phases of development. Maybe this is a beta, so I can set some of those limits. We're actually seeing a lot of interesting security companies, I would say, being formed and developed now that are entering the space that have given applications even additional like checks, right? So you can run, sophisticated like firewall or like AI engine, right, behind your application transaction, and you can allow it to authorize or kind of put delays on some of the transactions if they look suspicious. So I think the application layer kind of security add-ons is still early, but will with the last years particular continue to mature and scale across the whole stack. Yeah, so that's the first on a security. And again, like we do have a blog on our website. People can go kind of check it out and see how we think about it, right, and how we approach it. It's a very serious problem, and you can never be too safe. You just have to continue, invest in funds with it, and continue building a better technology. Does that make sense?
Yes, it does. So from the user perspective side, right. what was kind of like the user experience in like using Axelar?
Yeah, so today I would say there's still not the user experience that we want to get to, right? And primarily because I think today users are used to using things like bridges to move tokens around, which I think is like completely nonsensical way that has to go away, right? Like using kind of a bridges to like transfer tokens around is like making, a user be a human router, right? Or a human like air traffic control agent, right? That says like this packet needs to go, from A to B. So that's not what we want to end to, but, we're still seeing a lot of that build on top of Axelar and, being used. When the applications with these new architectures that we talked about earlier go live, they will completely redefine the user experience, right? And allow effectively the user to just simply say, I have a token, in my wallet. I see this application. I click and I go and use the application, right? And you don't have to think about where that application is even hosted, how to get gas on this destination chain, like all the message routing, token transfers in the middle and all that. This does require new application architecture build-outs, right? Like we talked about earlier. But this is the end goal. Like this is the end state, is where as a developer, you can build, you can scale with all these different ecosystems, but as a user, you can just go from your wallet, you see an application, you go and use it, and that's it, right? Like as simple as that. And so we are kind of actively working towards this experience, with a lot of the developers.
And you mentioned kind of the differences today with Axelar versus bridges. Could you touch upon it or go a little bit deeper into that topic? Like talk about like wrapped assets versus just message passing?
Yeah, so kind of a traditionally, right, bridges came about to just solve the need in the ecosystem to move value around, right? And, a lot of them were shipped very rapidly, so you end up with all these like pretty poor technical approaches, like centralized approaches that, wrap token in one format to another. Maybe you have like one or two nodes in the middle that are allowing them to mint, representation of this token on other chains, so like a wrapped asset. I think the only reason we have seen this is because all these ecosystems were born very, very rapidly, and there was no connectivity within that, right? So we ended up with like patch solutions. Many of them were compromised throughout the last year, unfortunately, as well. And the message passing paradigm kind of takes it, a step further, and it just says, now applications can talk to one another, right, directly. So in the same way, if you are coding an application on Ethereum, you can call other functions in other smart contracts on Ethereum, right? And you can execute functions with respect to them. So like, you can call a Uniswap contract to do a swap for you, right? And return you some result. And then you can, borrow against it, lend it against it, liquidate it, whatever you're doing. And so in the same way, your application can, with the message passing paradigm, can talk with other application. And so what that allows you to do, to kind of back to your point about the user experience, it allows you to take all the user interactions that they wanted to do previously, write down a program behind those interactions, right? And then run the program across chain that gets executed, right? So before, your experience was, I have a token on chain A, I want to get a token corresponding to it on chain B. I want to use this application. Let's say I want to swap it, and I want to end up with another token that I go and withdraw on another application on chain C. Right. So before, with the bridges, you had to do all those things manually. You had to like flip your wallets. You had to pay gas. So all those like 30 sequences of steps. And so now you can take this and say, okay, this is just the sequence of instructions or a message or a program. And you can ship that around, right? And like Axelar will help you ship that message around, execute it across all the contracts, and you don't have to do all those steps manually. And so that's the difference, right? Where kind of the traditional kind of bridge and token paradigms is put in all this work on the user, and now you can automate all that and you can ship that around.
I think that's a great explanation, and definitely helps simplify it. Going forward, or I guess like in some comparisons to other, I would say also bridges or messaging passing kind of solutions in the industry, like for example, Layer 0 or Wormhole, even like IBC or what Avalanche has launched recently with kind of Avalanche messaging. How would you compare kind of your technology solution that the Axelar team is building to what other ecosystems or tech solutions offer?
Yeah. So, it kind of depends, right? But on the very core of it, I would say most of the kind of bridging protocols that you see other than, sort of maybe Avalanche or IBC there are pretty centralized, right? So, kind of a layer 0 wormhole, like I think layer 0 is kind of running a small oracle, like 2 or 3 nodes. I think wormhole is running like 19 validators that they have selected. So that's a kind of a core difference, actually, being able to connect ecosystems that speak very different languages in a decentralized way is a hard problem, and like we're the only ones that are doing it. Within ecosystems, you do have some protocols that are that work, right? You have IBC, you have Avalanche, protocol that only works again because the subnets and everything that they're building like understands one another, right? And so you can build this protocols across homogeneous systems pretty efficiently, but across ecosystems with diverse stacks and deployments and like choices that developers make, Axelar provides the most decentralized approach. That being said, the second piece that I think is very different in how we approach is that Axelar itself sort of is a blockchain, right? And so that allows you to build kind of a programmability at the network layer that goes way beyond of what a message passing protocol semantics guarantee between A and B, right? So you can always have like a message passing semantics, and you can have a protocol between A and B. But interoperability doesn't stop there. Interoperability is about, like I said, like many-to-many routing. It's about like message translation as you get to it. It's about like path discovery and things like that. And so having Axelar as a blockchain allows us to then build a lot of these network types of primitives and objects at the network layer and execute them a lot more efficient for developers, right? One example of this, to be very concrete, things that we're doing to allow token transfer or deposits directly from like centralized exchanges or dumb wallets, right? So the idea is that Axelar Network can generate you what we call as like an address, which is a smart address, meaning that when a transaction hits this address, let's say you can withdraw a token like a USDC from Coinbase, then the network itself will know what needs to happen with that USDC, right? So say it needs to be routed to this destination chain. You need to call the smart contract on the destination chain. You need to execute it and then return the result to the user. And so now you have Coinbase users that can just execute a withdrawal and never have to have like MetaMask, never have to even pay gas on Ethereum, never have to think about it, but it automatically then executes like some decentralized program behind the scenes, right? So why we can do this is because, we program this path for the specific address, and we program the action behind it on the Axelar network itself. And so these are like examples of properties you can do at the networking layer once you have, the sort of concept of smart interoperability.
That's very interesting. And the Ethereum example, I'm assuming you have to pay for the computation or block space somewhere. Are you doing that on Axelar directly?
I mean, it depends, right? We can have a very simple model that we're doing right now, where if you withdraw like USDC, then maybe a certain fee is taken from USDC is automatically converted to pay for the computation on both Axelar but also destination chain, right? If you execute some smart contract on destination chain, somebody needs to pay gas for it, but that can be withdrawn from the asset that you're interacting with directly.
That makes sense. And then on the decentralization front, do you have more like concrete metrics on like validator count that you can share for Axelar?
Yeah, so I think right now on the main network we're running with something about like 60 validators, right? But the other important property that we actually did, for the cross-chain message passing, we implemented things like quadratic voting, right? So one of the issues with a lot of proof-of-stake validators, even if you have a lot of validators, but stake gets too concentrated, right? And so you end up with a slower, a smaller attack surface. So things like quadratic voting effectively say that, we can reduce a validator stake in a particular, consensus mechanism in order to, have more validators that need to reach a consensus, essentially. And so we implement like quadratic voting specifically for those things, because in practice we see, stake concentration being, a real problem. And that ends up, I think with a pretty good, diverse and kind of large validator set that you would need to compromise.
Is there a kind of like angle here with like a number that you would like to get to on the validator side?
Yeah, no, great question. I mean, hundreds, right, if not thousands down the line for sure. I think also, various technologies like zero knowledge proofs, right, availability of live clients across different ecosystems and so on and so forth allow you to make, even safer individual like connections, right? So, and maybe you need like fewer validators in that case. Maybe you run like zero knowledge computation across some of them where only one person needs to run it, but many can verify. So yeah, we're kind of, exploring a lot of those directions as well. And like the more the better, right? That's the point. That's what we're trying to get to.
Yeah, very cool. Definitely appreciate you kind of deep diving all the different technical nuances and also kind of being able to relate that back to the user experience. I guess maybe just wrapping up the podcast. 2022 was a pretty wild year in a lot of regards. How is the team doing? Are there any big lessons that you guys had while building kind of in this chaotic market, or things that you're looking forward to for this year in 2023?
Yeah, no, I mean, we're doing, fine, right? Like, thankfully, we're not affected by the things directly. And, we're pretty well capitalized for foreseeable future. And this is one of the things we, deliberately done over the last few years is making sure we have capital to continue building what we're doing. That being said, it's been a wild year, right? A lot of overnights, a lot of gray hair as well. The process. So I think we're fine. I think the team is really strong, and we have an amazing, problem that we're solving. And, as I tell to everybody, look, like we have seen effectively, FTX and like Celsius and all these things collapse because you could not have built decentralized applications like that right before. Right? You could not build an equivalent of FTX in a blockchain, right? Because inherently FTX requires things like interoperability, right? It's basically trading tokens from one blockchain to another, and unless you have decentralized connectivity across all these stacks, you couldn't build that, right? And so I think that just reinforces how important it is to solve this problem, so we can, all the kind of a front ends and all the centralized systems that have been built over the years in this space, we can now go back and say, how do I offer the same level of connectivity, the same level of user experience that those Web2 systems offered on top of blockchains, right? But in a more decentralized, more transparent way. And so I think that's incredibly important, right? And, I think we're as a team just staying focused and true to that mission.
I fully agree. In 2023, is there any specific items that you are looking forward to or that you want to see built either on Axelar directly or in the more broader ecosystem? Yeah,
so I wrote a short tweet, I think, about a couple of weeks ago that I said, let's 2023 be the year of boring crypto, right? And like the concept of boring crypto is it's sort of from boring cryptography, right? Where it's like you want to design systems based on like fundamentally strong and robust cryptographic primitives that withstood the test of time, right? And so I think as we get into the next phase, I think it's important to take that step back and really think about like, what are the infrastructure pieces that we're missing? Like, what are the building blocks that still need to be there to scale, right, in a long term, in a sustainable way? So to me, I think, you asked a lot of the right questions, which is like, what does the user experience need to look like, right? And the user experience need to look better. And, I think as we're working with a lot of developers, those are like specific things we want to think about, right? Like, how does the wallet experience need to look? How does the application experience need to look in this process? I think, I'm just encouraging, I think, everybody to just take a step back, right? And, let's understand what the building blocks that are missing. In some sense, it's a good, problem to have because we have demand, but we don't have this infrastructure, answers yet. I think if you look at the history of the intranet and everything that's been happening, is actually reverse, right? Like the interoperability communication protocols were worked out like 20 years before a single application used them. Right? Like there was all researchers and military use cases, like testing and trying to design technology that can withstand like nuclear attacks, right, and things like that. So a lot of thought went into it, and I think in the blockchain space we'll find ourselves in a reverse position where you ship something and like it may get actually millions of users tomorrow, right, or millions of value, not millions of users, but like millions of value at least flowing through these protocols. So it is scary, it is. You have to be careful, and I actually look forward to hopefully at least this year being being at a slightly slower pace.
For sure. Kind of refocusing back on the builders, and as you said, focusing on the basics and the infrastructure. One thing that I've also been super fascinated by is there has been quite a bit of like TVL, or as you said, millions kind of flowing, even billions in these ecosystems, but there hasn't been as much user activity as I would like. I think when I look at like Dune Analytics with OpenSea and Uniswap, each of them respectively have like less than 5 million like lifetime active users interacting with their smart contracts. What do you think we need to do as an industry to get that to say 100 million? Because that was kind of the original thing that really excited me about crypto, is like having this technology and the power of like many people.
Yeah. I mean, I don't think there's a single thing, but it's both like scalability issues on the networking layer, right, at the consensus layer. You can't throw 100 million of users, today at today's instantiations of blockchains, right? Like, we're gonna collapse, frankly. So you still need a lot of like infrastructure work. You still need to continue answering these, scalability issues, whether or not, it's kind of vertically improving your stacks or horizontally and things like that. And then the second big point is what we talked about is the user experiences, right? So things like account abstractions, right? I think I'm pretty excited about a lot of the directions in those works. Is that how do you allow a user to just use the application without having to, think about gas payments, right? And, latency and things like that. So account abstractions properties help you, things like wallets that have multi-factor authentication and or, wallet recovery properties, right? So I think one of the things that you find as people enroll is that it's a new world for them, right? And the question is, do you want to learn this world? And so having user experiences that are easier and easier, I think, is very important. And then I think the third point, which I think is quite important, is that kind of the whole Web3 industry, or blockchain industry, it sort of runs completely in parallel with everyone else in the world, right? That's sort of different users, right? That mostly don't like other systems, right? That's different funding, it's different community, it's its own world. And so I actually think like finding bridges, right? And finding use cases, like back to the point, like, here's a real problem, right? That needs to be solved, like things like payments, right? Giving access to financial instruments to people, we have not solved any of those things we've been talking about for the last 10 years, right? But I think the infrastructure is now, getting to a point of being mature enough that you can go back to, a lot of these questions. I think like, payments is getting renewed attention, as well. So yeah, I think like finding the bridges with other communities, right? With other real problems that people have, and the problems we've been talking about solving but haven't really solved, I think is still important. So yeah, unfortunately, there's no single answer. It's everything from the stack that has to be solved. But I think that's why it's so exciting, right? Like there are opportunities, there are things we can solve. We just need to continue staying focused.
I fully agree. Well, I think that's probably a perfect place to end it on. Thank you so much, Sergey. Really appreciate your time. Again, appreciate you having the conversation with me in Spain and letting me badger you for a little bit. And thank you so much for coming on the podcast.
It was great. Always a pleasure chatting with you.
Perfect. Thanks.